open the doors.
I guess it's not even like it's
feed it through. What it's testing is the components that are fitted by the lasers at the other end. So it discharges all the capacitors to make sure there's no voltage in there at all. And then it'll open and then it'll test it. Even things like the relays, it'll actually switch them backwards and forwards to make sure they work. So obviously whatever it was on R12, it took it a while to test it.
it's a seriously clever bit of kit, isn't it?
Oh yeah. You see there, the switch. You actually switch the relay.
Yeah.
Then at the end, if it fails, which they do quite often, it will give her a bit of paper saying what it's R27 is wrong.
Yeah.
So then she can find R27 and find out what's wrong with it. In the case of that one, it passed. We knew it was going to pass, so I was just put it there. She's not silly, she's not going to give us one that fails. I would say, but the thing is, yeah, you do this because it cuts down on any problems that will happen further on down the line.
Yeah.
Because it can happen. I mean, electronics can go wrong at the drop of a hat. Yeah. This is not the best thing to do, but it's the way it is. That's why we test so many times.
There's an accident between A27, which is Pevensey roundabout, and B2182, which is the battery lane that is common.
There's never anywhere one of these working when you come through, it's always the way. These are auto insertion machines. Basically what you've got, you've got a head mechanism at the other end. You tell the computer what you want, what board you want to load. There's a valve power board with the one that we just saw being tested. This is the first stage. Glass has gone through that and then that machine, and what they're doing between them is put all the small components in. Nothing falls out because they're all bent over. So you tell the computer you want to load this circuit board. This one loads what's called the actual components, these ones. I'll tell you what, it will then take the right component, cuts it off, drops it onto a chain, takes it to the front of the machine, takes that component, bends the legs over, puts it through the board, bends them in the other direction, cuts them off. But it also measures it.
Yeah.
And it does that at 6 a second. Or 22,000 an hour.
Yeah.
They can actually work quicker than that. This one's capable of doing 10 a second. But it tends to break down more when you do that, because it is very mechanical. That machine over the back is only 5 a second. It's a little bit slow because it puts what's called the radial components, where the legs come out the bottom of the component. But it still works. And also transistors, but the thing is, we know that these components that are fitted in here, although they're all loose, they're the right value, in the right hole, and the right way round.
Yeah.
So it cuts down on any problems that may happen. You can't get it wrong. I mean, let me put that back. If we swap two of these over, took that up and put it there, swap them round, it would tell you immediately they were wrong.
Yep.
Because it measures them as they go off. And if you cut out, if you remove, say, half a dozen, it will keep pulling until it finds one. If it doesn't find one, then again it stops. So it can't put them in the wrong order. So it can't get the components out of order. Because imagine if you got them all one out of order, what mess it would make of the
Oh, good, yeah.
But it can't do that. I mean, provided we program it properly.
Think how long it would take somebody to take each one of those.
Well, that's it. But we still do that.
Solder on.
We still do it. slightly different, you still do it. So you can come down this way. And you can see we still do it. As the lady you can see there is doing it. What happened is these boards come in blank, they put the rivets in, they'll then solder all the wires on, and then put the components on. Now we go back to the JVM 410 from empty circuit boards, so put the 500 odd components in there. It's about 22 minutes.
Yeah.
This will take about an hour to put 39 components on a board. That's why this, which is what the lady is building there, this is an 18 watt valve combo, and it's a tad short, I think, of £1,600 because it's hand built.
Yeah.
If you take it the next stage, once this is done, that takes about an hour. The chassis will come down in the same way. They'll come down to the operator, the system there. The gentleman then take the chassis and load it completely up with all the transformers, anything else that's exterior.
Yeah.
That will take probably about half an hour or so. And then this lady who does wiring as well, she'll take a circuit board like this and that chassis. It'll then take her 4 hours to wire it in. So you're looking at JVM 410 and your amplifier, your little 1 watt, would take probably about 45 minutes to go from all the different components to a complete chassis. It'll take about 45 minutes. This takes 5.5 hours.
Yeah.
That's unfortunately why it costs so much, because I mean the single most expensive thing in any manufacturing is human.
Yeah.
You take something like, do you have a mobile phone?
Yeah.
Is it an iPhone by any chance?
It's not.
No, it doesn't matter, it's alright. The only reason I know that because I know the iPhone. I took 2 guys around the other day and they work for Apple
Yours is.
Research.
Yeah, mine is.
Yeah.
They produce an iPhone every 3.5 seconds. Continuously, 24 hours a day, 7 days a week. They don't stop. And in that factory, producing those iPhones, I think he said there was either 6 or 8 people work, that's all. The rest is totally done by computer. The only humans are the ones that are there in case it breaks down, and the ones that actually drive the forklift trucks to load onto the lorries.
Yeah.
They're the only people that work in that factory. Yeah. Everything else is done by computer. It's built by computer, checked by computer, and even designed by computer these days. But they still cost you, what, 500-600 quid if you buy them, because they can. What we tend to do is we make them like this because we can. That's what people want, and that's why they cost so much money. Because they're made here. Now, if we made your amplifier in China, in bits, and had it shipped over here and put it together, we could probably sell it for half the price and still make the same profit. But we don't, because we wanted to make it here. We didn't want to make a prestigious bit of kit like that in China. We do have stuff made in China. Our MG range are made in China, but it clearly says on the amplifier made in China. It doesn't say assembled in Britain. It actually said made in China. Now we're not trying to cover anything up in that sense. Like, I'm not saying other companies do, but I'm not saying that. So I mean, literally, you can see it's done by hand. The time we spent here, she's put in maybe half a dozen components, and she's good at what she does. I'm not saying you're too loud because you want to raise.
Wait, yeah.
But she is. I mean, I can do that.
Yeah, I can do that, but it takes me a long time.
I could do it as accurate as that lady's doing, but it'd take me an awful lot longer. I mean, she only has this here, so we're here, so it looks like she's looking. She knows what she's doing. These days, I mean, it's literally, it's familiarity, that's the whole point. But also, what you can see, if I show you on this one, before I make the bold statement, I'm going to check. I don't know if you know about electronics, but with resistors especially, they have a 4th or 5th band, which is normally gold, silver or red. That denotes its tolerance, how accurate it is. So that's 100 ohms, It's a gold bar, so that's going to be 10% either side of 100 ohms. If you notice, all the gold bands are all in the same direction.
Yeah.
Has no effect. A resistor can go either way around. It does not matter the way it works. But we do that because it looks nicer. Pure and simple.
Maybe it's sad, but it matters to me as well.
Yeah.
Well, this is it. I mean, we did. I mean, one of the reasons why we did it, we didn't used to do it before, but we had a customer who bought one of the 950 900 watt super leads, and they're about £3,000. And he complained. He wrote, I think he emailed in or wrote in and complained that one of his resistors is the wrong way around. So we invited him down. He came down, took it into service. They unsoldered it in service, turned it around, put it back in, and soldered it back in for him, and he was happy. We found out afterwards what he'd done or what he was going to do, and he did do in the end. He took it to a professional photographer, the chassis, had it photographed, then had it printed onto a little canvas so it looked like an oil painting, had it framed and put above his fireplace. And he wanted it. He said he wanted it looking right.
Yeah.
And that's the way. So now they literally do it. So they're all the right way around.
Yeah, because you would buy one from her.
I've never found one yet.
No.
I've never found one yet.
Oh, yeah.
Not yet.
I do never will.
But we try our best. Thanks, my love.
Thank you.
Thanks.
Everything comes together. You have to walk around it twice now because it's just moving it all about. It's being redesigned. Make it more efficient. So what's the cab you're waiting for?
It's the matching one that goes with the.
The one that had done for the.
Yeah, I know. I'm trying to think of what the model number is, but I don't know.
It's the custom shop JTM 145 cab. I don't think it had a particular
No, I don't think it has.
number.
I thought I might be able to see it, but I can't. So it may well have gone already. It's been gone through. Because the reason I say that is what you see, all those chassis you saw, and all these wooden boxes all belong to somebody. We only make to order.
Yep.
So somebody orders something, we export to 89 countries. So a country orders a 40-foot container, they pay us, we then manufacture it.
Way to do it.
Oh yes, it's the way Jim always did it,
Oh yes.
and it hasn't changed. The obviously exception to that is this country, which is the most awful as far as we're concerned, because we deal with about 320 dealers, and they'll order one amp, or they'll order one cab.
Yes.
Yeah.
And of course then it makes it slightly harder for us to jiggle it about. So with the British market, we do have a small stock, but not as specialised units. That's why there's a delay in getting it, because they're the sort of things we don't want hanging about.
Yeah.
But on the covering side, as you can see, there's no machinery involved. It's literally all done by hand. They'll take a cab. The wooden box itself is manufactured in the wood mill, which goes along the whole back of the factory. It comes out, it goes through that metal box there, which has a carousel inside, which actually is hooked onto there because these days we use the water-based glue. The box has to be warmed up to about 50 degrees C to make it active. The covering itself, as you can see, is cut to width. Then goes up the bench over there and it's cut to length. It's all marked down in different lengths. It's then sprayed. At that point, the glue isn't sticky. You can wipe it off because it has to be taken up. So that there's a conveyor in the back corner, that sort of like biscuit coloured thing, and it warms the cabinet up. It warms the material up with the glue to make it active. And then you work like any normal impact adhesive. The advantage you've got, like your good self, and I hope you never do it, but the advantage you have got is if you manage to damage the covering one day, whatever you're doing, taking out the back of a car, or you catch it and rip the covering, when you stop moaning about it, take it indoors or wherever, get out the hairdryer. Most households these days have hairdryers. That's all you need to do. You'll peel it back and you see the glue on the material and on the wood. Get the hairdryer on it. We'll keep it on the move. Depending on the power of the hairdryer, it takes 2 or 3 minutes. The glue will warm up and become active and stick it back down. It never actually goes off.
Yeah.
It never actually goes off. And you stick it back down, let it cool down, it'll be perfect. It won't come off again. Not a suggestion you go home tonight and try it.
Yeah, don't take the corner off just to see
Don't need to rip it off just to see if it does, but it does work, I assure you. So what'll happen once the cover come over? It may well have already been done. When's it set to come out on Friday?
Yeah.
It'll be done by now, I should think. I've been packing. The units here, they're all ready, they're all been done. You can see what I mean now by the carousel. This will just keep going round all day. These are the next order. They're just allowed to warm up. In here what we do is inside, like your amplifier, plus you have a grill on it so you can see in, we spray the inside black. It's just a water-based black emulsion. Nothing special in that sense. Obviously water-based these days have to be. It's just sprayed on the inside, this side, and then when they're ready to come up, the glue is sprayed on the other side of this. I say these will just keep going around until they're ready to be taken off. You see what I mean now? These, this is the next order. These will just keep going. Those circuit boards I showed you at the very beginning, not the 1 watts, but the JVM, these will be the cabinet for them. So that's how tight we work. Now, we don't do just in time. We tried that. We can't do that. It's not there. We just can't do it. But we do work out that this will be going. So somebody somewhere in the world owns that.
Yeah.
So I say we can go in the wood, but we can't wander around. Noisy in here. We can't spend any time in here more than a couple of minutes without putting the air conditioner up. You can't wander around in theory without having steel toe caps on, so it's just for safety reasons. Right, shall we
Yeah.
I mean the fret cloth in itself, regardless of the sort, I mean this, it's actually paper. It's actually paper. It always has been. It's all, even that there, it's all actual paper. You can see, it's actually just paper. I mean, it won't burn.
No.
It's got the inhibitor built in. It won't change colour. But what it means is because it's paper, we can do that sort of thing with it.
Of course, yeah.
You can have anything, virtually anything printed on the front of it. And almost anything. We do have our limits. We won't do anything rude. We won't have any swear words. But the single worst thing is actually copyright. Just for those over there. This gentleman here put these together. So we'll take the wooden box.
There it is.
Oh, done it.
Is that it?
There you go then.
That's it.
What happens is on the conveyor, it goes to a little room there, and the last thing that happens to it is as the guitar plugged into it, it's played through.
Yeah.
Every single amplifier we manufacture, or cabinet, every single unit is probably the better way to put it, will go through the room. We have two of them, depending on which one we need. We'll get manufactured, we'll get tested, we'll have a guitar plugged into it. People think what a great job. We make about 150, 200 a day.
Yeah.
You don't get a chance to pick the guitar up in most cases. Things like this, I notice I'm not touching it, so I'm not going to get the blame. Things like this, I'll have a little bit more done to it because it's a hand-wired unit. It'll have the guitar picked up and it'll go up and down the chords, make sure there's no buzzings or rattlings or anything like that. But something like a standard amplifier, the guitar doesn't even stand. Excuse me. You'll strum a chord, turn the control, strum another chord, do the other channel.
Yeah.
And that's how it'll do it. So it'll literally take a matter of minutes to do. But everything is definitely tested.
Yeah.
Huh?
I'll go get it.
Oh, mine's alright, yeah.
Actually, we're a bit early. We're a bit early actually. There's a cabinet on the hand-wired cabinet. It's this gentleman's.
Yeah?
He's got to pick it up Friday or Saturday from
Oh well.
the shop.
And you want it to see it go through?
No.
The hand wire what?
Cab. Just
Oh,
a
cab.
cab. It's
Yeah.
for one of the
By the Anderson.
Anderson's units.
Oh right,
Gentleman's already got the head and he was just waiting for the cab to
yeah.
come through.
Oh yeah, I think that's the last one today.
Yeah.
Yeah.
So, and we don't know it's definitely yours, but it's certainly
Definitely, but
Definitely one of the bunch.
It's certainly one of them. Anyway, this is Mark, by the way. Mark has probably the most important job as far as production's concerned, because he's final check. As you can see, he'll give them, when the unit comes to, it's in a work environment, so he'll give it a quick dust down, a quick check to make sure there's nothing obvious missing, you know, all the corners are there, all the feet are on there, whatever. If he's happy with that, in the case of an amplifier, make sure there's an amp in it, if you're meant to have one. The next thing he does is actually safety check. It's that big box there called Claire. It's actually a flash test and earth leakage. If he doesn't get a green light, it means it's failed. You know, as I've always said, it's we've been going 52 years. We haven't killed anybody yet, but we don't want to start. Probably not our best thing.
It gives you a bad reputation if you start killing people.
It does, it does. So once he's happy with that, he'll leave it on by that hand, he'll give it a dust down, just check there's no dust on there. Handle's got the screws in, so it's not going to fall off the first time you pick it up. There's a little JVM, it's only a 2-channel, so it doesn't take quite that long to test. Check it's square, check there's no scratches on the front panels. We already checked the back panel when we came in, he was doing that. He was happy with that. Turns everything down. So he doesn't need it, have his ears cleaned out too often. Now the exhaustive guitar test.
Yeah, a quick flick with a guitar.
That's the one. I mean, you're not testing just to make sure it sounds good.
No,
You're making sure everything's connected. straightforward and simple as that. Looks like we're going Canada.
Canadian, yeah, this is what I'm doing now, yeah.
Because he's got a memory for channel change, the last thing he does is empty the memory in case there's anything in there. And that's it, all done.
Yeah, here's that, another good one.
Well, they're all good ones, aren't they?
Oh,
They
yeah.
never get any failures. Not many anyway.
Very rarely.
Yeah. It's normally when we study it they go wrong, which is good because it shows we test them.
Oh, true, yeah.
Yeah, like we have the occasional one, but not that often.
So we go on, we'll leave you to it.
Yeah, okay then.
Thank you.
All right.
Thanks.
As I said, we try and make everything ourselves. On the engineering side, we make all the chassis. We don't, nothing's bought in. All but 3 of the chassis are made out of smart steel. We use 2 sorts. We use still, I mean that's just a few chassis, but it's still exactly the same. It's still mild steel. The only thing is, because it's called Zintex, it's just pre-coated in zinc, so it won't rust.
Yeah.
The hand-wired units are just made out of standard mild steel, but they have to be, because tradition dictates it. What we do, this is a little 20 watt, we weld it up. With the Zintex you can't weld it because it breaks down the weld, the air Zintex. But these are welded up in their raw state. Just there, we do it all ourselves. These are then sent off to a company which is about 2 miles away who actually then zinc plate them.
Yeah.
So they'll look like that in 25 years' time, as will yours.
Yeah.
Yeah, it won't go.
Do you have a machine that welds them, or does somebody actually sits there and
that man there with a black top on, all done by hand. Oh yeah. He's not as good as the guy we used to have. Well, he is, he's very, very good. But the guy we used to have, he retired last year. And I'm sure if you asked him to weld 2 bits of paper together, he would. He could weld, I mean, I've never done welding, so I can't comment in that sense, but the aluminium is one of the hardest metals to weld because you can easily blow holes in it. And he had a few, as Steve did when he first learned how to weld aluminium. He could weld steel without thinking about it. It's very easy to damage the chassis. The old guy, he could do it with his eyes shut. But it is literally all done by hand. There's no machinery involved. I'd say, other than the welder.
Yeah, was that clean? I wonder whether it's done by a robot.
When you say he's the robot that does the welding. Badly. But no, it's not that bad. I'm just saying the aluminium's difficult. He hates aluminium.
Mild steel, not a problem. But aluminium is something else. Something else will do.
What was his guy's retired? Can't remember his name.
Pete Jarvis.
Pete, I mean, you could ask him to weld 2 bits of paper together.
Yeah,
he'd do it for you.
He'd done welding from years ago, done his apprenticeship, and like Phil said, he could weld paper together if you asked him to. He was that good.
But we do it by hand because it's tradition.
Yeah.
I mean, you could probably get away with certainly that little 20 watt. You wouldn't need to weld it because it's literally it's a solid chassis. Yeah. It's a very small chassis. You probably get away with that welding it. But our customers expect it to be welded, so that's why we weld them.
Yeah.
I mean, it was with the stand them up with the Zintex. What we do with Zintex is it's actually pressed together.
Yeah.
So you've got a bit of metal underneath. So when it's stamped out, when it's all folded up, they come together. Then you just exert a lot of tons of pressure on that. It just fuses the bits of metal together. Doesn't break the zinc seal, the zinc coating, so they don't rust. But it's just as strong.
Yeah.
I mean, it's all not very heavy, but that's a basically 100 watt chassis.
Yeah.
I mean, I've had people in here like, what is the relationship? I don't want to